Hi, it's Jan Beta, and today I'm going to try to fix a special Commodore 64. So here's the board I'm going to work on today, and the story of this board is kind of a bit sad because this was sent to me by my late friend ZXkim81. I think we exchanged it for a Commodore 128 that I had, and he sent me some other bits I don't quite remember. Sadly, Kim passed away a couple of years ago. Kim was really well known in the retro community. Very much one of the nicest persons you could ever meet. I didn't have the pleasure to meet him in person, unfortunately, but we had online conversations and we sent things back and forth. And when I posted about working on this board on Mastodon recently, the responses were kind of similar to my experience with Kim. Kim is very highly, or was very highly regarded in the community and was in touch with many people in the community. And yeah, sadly, I'm not going to be able to bring Kim back to life, but at least in memory of Kim, I'm going to try to bring this board back to life. I think about Kim very often, and I recently remembered that I have this board, which I started working on shortly after Kim sent it to me, but didn't find the fault. And I kind of learned things in the meantime, as we all do, and I'm pretty confident that maybe today I'm going to be able to fix this with my new skills and new tools in memory of my friend ZXkim81. Yeah, Kim recapped this in 2017, and that's, I think, when I got it. Around that time, around Christmas 2017, he sent me this. So that's the sad part of this video over with. Let's try to fix this board in the name of Kim. So the state of this board is that Kim put new capacitors in. I actually had to do some work with this capacitor here that I needed to replace again and put a little botched wire on the back because one of the traces was lifted here. That was my first suspect for this not working correctly. Kim also put heat sinks on here on all the custom chips basically. I replaced the kernel ROM because yeah, the fault that we're going to see is kind of pointing in the direction. I also replaced this 8701 timer chip already, I think, replaced the CIA. I'm just going to show you the fault, I think, because then everything should make more sense. So here's what we get when I turn this on. It seems to nearly fully work, but we don't get any cursor flashing. That should be here, which it isn't. And it doesn't react at all to keyboard input. Can't even run, stop, restore, soft reset this. So something's wrong. In most cases, if the cursor is not flashing and something's wrong with the keyboard input, this CIA here, located at U1, is the culprit because that's responsible for the flashing timing of the cursor actually, and for the keyboard input as well as joystick input, I believe. And there's another CAA chip here for other I/O, like the user port and things like that. And I socketed this chip and replaced it with a known good one. I tried this one in another C64. And this CIA actually is fine. That's the original one that was in here. I also tried, that is another culprit, sometimes for the cursor not working correctly, replacing the kernel and basic ROM, which is combined in these short board C64s. I replaced that with an EEPROM that I burned. That seems to be fine, works in other C64s again, and we didn't get any change in the fault. So next thing I tried was some general timing stuff. I think I replaced this 8701. I believe it was socketed on this board, as it is on most C64 boards. And the VIC-2 is also socketed on this one. I think I also tried another one. It's always a good idea to replace the easy parts that are socketed if you have replacement chips at hand, and try if that makes a difference, and try the chips that may be faulty in a otherwise working system to check if they are the culprit for this fault. But they aren't. So yeah, that's what I did so far. Replaced this capacitor because Kim cut a trace there. I put a little trace on the back of the board. We're going to see that in a second. I tried to replace the CAA, which didn't make any difference. This didn't come with the SID, I believe, so this is just like it was. The sound chip goes here. But yeah, other than that, it does somewhat work, and some games work and things like that. So let me show you what it does with a cartridge, for example. So I have my diagnostics cartridge in there now, the dead test. And as you're going to see, this basically passes. It just shows me different times for the CAA timers that are going to appear. So look at that. We have two time of day clocks here that are for the two CAA chips. These CAA6526 MOS chips have a real-life time of day clock in there, basically, even with alarms you can set and things like that. And as you can see, we have a difference here. Usually this shows the same time if the CAAs are working correctly for both CAAs, and this is off. Usually there's one is AM and one is PM, but they are showing the same digits there. Otherwise, the test passes. So I still suspect something's wrong with the CAA, but it's not the CAA itself. So I'm not quite sure what that is. Let's take a look at the diagnostic ROM, the Commodore diagnostic ROM. That's the diagnostic ROM, and we have the same behavior for the clocks. I can already see that they are off by an hour. One of the clocks is not running correctly. So there might be something wrong with the timers that go to the CAA, to the one CAA there. Maybe there's a broken trace somewhere that I didn't catch in my first repair attempt. Yeah, I'm going to have a look at that. Maybe I put the socket in the wrong way or something like that. Not quite sure. Oh, now it crashed even. I think the diagnostic totally crashed. That's not good. Yeah, that just utterly crashed. That's not a good sign. So something's wrong, and it seems to be somewhat related to the timing of the system in general, and especially to the U1 CAA number 1. So we are probably going to break out the scope and have a look. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They also do CNC machining, 3D printing, sheet metal fabrication. They can populate your boards for you. The quality of all the products is excellent, the service is superb, and delivery is fast. I highly recommend checking out the link in the video description should you be interested. Back to our troublesome C64. One interesting thing I found while working on this, should wear my ESD wrist strap again, is that as soon as I put, this is a nano swim SID, is SID replacement, as soon as I put one in here, in the position it goes, the SID position, and I just turn this on, we actually get a flashing cursor there. And the keyboard input works. And it seems to bring the system back to life. But that should not be the usual case. So I am not sure what that's about. But we get a regular flashing cursor here. And I guess we can even program stuff. Yeah, it seems to be completely working system, but it should work absolutely fine without a SID in this position. So something is marginally wrong here, I guess. I'm not sure what, but it's definitely not quite working the way it's supposed to work. It should work perfectly fine without a SID for the basic functionality. Just the pedal inputs won't work, and of course you won't get any sound without a chip, without a sound chip. But yeah, without a sound chip, this one doesn't even display a cursor. So, we're going to have a look. I'm just going to break out the scope and check some pins on the CAA, I guess. Maybe I'm going to resolder the pins on the socket. Definitely going to replace the SID socket there. That is one of the nasty kind. This socket here is one of the cheapest single wipe sockets that Commodore sometimes used for their systems. These are notorious for failing and not making good contact with the chips. And in fact, my Nano Swin SID, which has these round pin headers here, turned pin headers, which usually fit fine into dual wipe sockets or precision sockets. they don't quite grab very well in this one. But yeah, I guess what I'm going to do is to desolder this and put a proper socket in here as my first step. Maybe that even fixes our problem, and then scope the pins on the CAA, I guess. But I guess something is not coming through here or something like that. Not quite sure. I'm going to desolder this, which shouldn't be a huge problem, and have a look in the area there. Maybe visual inspection is already enough to show me what's going on there. Traces all look pretty good, actually, from visual inspection. I'm just going to desolder it completely. It should run without a SID and without a socket, obviously. Desoldering stations making strange noises, I'm sorry. But yeah, I'm just going to resolder all of these on the socket here, reseat the CAA, and try again, I guess. It must be something that's not quite correctly arriving at our CAA. Maybe one of the timers, I think there's a timer clock signal, a system clock signal, not the time of day. The time of day is generated in the CAA, and it has two timer inputs, I believe. One is from the mains frequency, basically. That's what the time of day clock is generated from. And the other one is a processor clock that's provided by the CPU. So if one of those is missing or incorrect, we are going to get the result that we had here, I guess. These are actually better boards than the old breadbin boards, so they are not as easy to solder on, but it's also not so easy to break the pads on these. Yeah, that worked. It's both positive and negative. Good news and bad news. In general, these are better produced, but not so easy to work on. I can literally just pull it out of the socket. These sockets are so crap. Okay, let me show you this. I can just pull the socket off, I think, without even removing the pins. Yeah. There we go. Some pins are still in there that I can just hold with a small pair of pliers. And this thing just goes to the trash, I guess. These are crap anyway. So I'm just going to use some small pliers and the soldering iron from the backside and pull these out while I heat the solder. So I'm just removing all the solder here and clean this board up to see if we have any problems here. It is a bit strange that this starts working with the SID in there. I'm not sure if the clock signals pass through the SID at all, but yeah, maybe something else. Maybe something is shorted to ground or something, I don't know. So this is what we ended up with. Pretty clean pull there. No lifted pads or traces or through-hole plating. I don't see any, at least. So yeah, let's see if this helped. Maybe we just have a working C64 now. Okay, I don't have very high hopes for this, but let's see. Nope, no cursor. So why on earth does a nano swin SID, of all things, make this thing work again? I'm going to get the oscilloscope out and some pinouts for the 2526, I think, and see what the clock signals are. So here's a pinout that I just downloaded from the internet randomly. You are going to be able to find this on several websites. This is what the CAA chips look like, 40-pin dip chips, obviously. We have a ground pin, we have a voltage supply pin that I'm going to check. We have a TOD, which means time of day pin. I'm not sure if this is the input or the output. I think it must be an input for the clock frequency, basically, from the mains. And we have this Phi2, which is a general purpose clock input that is the clock for the whole chip, basically, for all its operations. We have data lines, of course, and we have the I/O pins, which are the PA and PB pins. The rest of it is just the usual stuff, basically. Interrupts, we have the read-write, chip select, a flag. I'm not quite sure what that is for. I didn't look up the datasheet for this completely, I'm sorry. But the datasheet for this is also available. I'm going to link that in the description if you are interested in using a 6526 in your own project. You can find the datasheet. It's not a good idea to use these anymore, I guess, because they are getting rarer and failing. But we are going to look primarily at the clock pins here. Pin 25, which is the Phi2 clock, which should time all the operations of this, including the cursor flashing and the I/O and things like that. And that should come from the processor, which has the Phi2 out on pin 39 here. So this is the signal we want on this pin. And we're going to check if this comes out of our processor, which it probably does, because the other CAA seems to work fine. But yeah, that's my main suspect at the moment. I'm not quite sure how the TOD works. It might even be an output, and the Phi2 is the clock that also is responsible for the time of day clock. I'm not sure. But at least this Phi2 clock is coming from the processor into our CAAs. Both of them have the same pinout. Obviously, they are the same chip, just used for different things in the system. I already powered on the oscilloscope. Let's have a look. So let's see. I'm powering on the system without a SID chip, because obviously we don't even have a socket in that position at the moment. That should be pin 25 with our clock. 21, 22, 23, 24, 25. This should be our Phi2. And that looks good. That's a clock. That was my main suspect. Let's see what the TOD pin says. That should be pin 19 now. That also shows me something. Okay, that's some sort of clock too. That actually looks good. This is the voltage supply. That's 5 volts. That should be fine. Ground is ground at ground level. Let's look at Phi2 on the processor pin. Pin 39. That should be this one. Yep, that's Phi2. Does it look the same? That's 5 volts peak to peak. That's also 5 volts. So the clock is fine. That's disheartening. I was suspecting this to be the culprit. I'm not sure. This arrives there. Everything seems to be good. I'm just going to probe the other pins, like the data lines and things like that. Maybe something else is wrong. Let's see if our CAA gets the reset signal. Oh, that's on pin 34 actually. 39, 38, 37, 36, 35, 34. So this is our reset signal when I turn this on. Okay. That should go high. So our reset is not coming through. So the chip is not initialized. That makes sense. The reset signal goes to the SID chip in normal operation. Maybe it doesn't arrive at the SID chip correctly. Or maybe it does, and there's a broken trace there. So this doesn't seem to work correctly. The reset. That makes sense. Let's check this pin on the other CAA, I guess. So let's see what that does. Yeah, that goes high after just a second. This is the normal behavior. So if this goes high to 5 volts TTL level, the chip is initialized. And the general reset in the system seems to work, otherwise we wouldn't have the startup screen. So the processor and things like that are initialized correctly, just not our CAA. Since we had a result with the SID chip in there, I'm just going to see if the reset signal arrives at the SID chip here. Maybe something here is pulling that low. We're going to figure that out, I guess. That's not a big deal, really. We could just, in theory, just botch a wire from another chip to that pin. And this should initialize. But I kind of want to know what's going on here. So here's the pinout for the 8580 SID, which is the newer version of the sound interface device that was in the Commodore 64s. Sounds slightly different than the original version, the 6581. A very similar chip, just more modern, and it uses other voltages. The old one used 12 volts on one of the pins, and this one uses +9 and +5. The old one uses +12 and +5. Pinout is the same. The rest of the functionality is also the same. We have Phi2 on here as well, and reset. Pins 5 and 6. So I'm going to check both of those, I guess. This should be our reset pin. Watch the scope! Haha, there's no reset coming there. Let's see if phi 2 is there. Yep, phi 2 is actually fine. The one I was suspecting. So we don't get a reset signal coming here. This should be high. The sound probably wouldn't work. I didn't even test that with the nano swin set in there. So our reset is not coming through to these two chips at least. Everything else basically seems to be initialized. Okay, I'm just going to see where that trace goes and follow it, I guess. I marked some of the reset pins that are important here. The one on the processor, this is pin 40. This is where this originates basically, or where it goes to as well. This should technically go to these pins as well, I think. It's all one connection. Let's see if this is the SID chip. This is our reset pin. That should go to the reset pin on the CAA. Yep. That's transported there. There's no connection on this one here. This should go to the other chips as well, I guess. Let's see. Do we have this on the other CAA chip? Yep, indeed. The processor reset pin should be connected to all the reset pins on the other chips. And it isn't connected to the SID chip. Let's see what's wrong there. That is going through a bridge on the top side of the board to this connection here. And that should be alright. Just going to trace this. Yep, that connection is here. That goes over here. Down here. And there's a break in the trace. Okay, that was nearly too easy. So here's our reset pin on our SID that is connected with the trace to this point here. This via connects to this trace, which goes all the way down here. And next to this electrolytic capacitor, I believe, that Kim replaced, looks like there's a break in the trace. So I'm just going to clean this up. Might just be short, but I think the trace is ripped there. That sometimes happens, especially during desoldering. If you are not careful, you rip traces that are too close to the pads you desolder. No big deal really, but this can be super nerve-wracking to troubleshoot because it's not really clearly visible unless you look really closely at this. Yeah, there's definitely a break there, I guess. This should go to here. Yeah, no, it doesn't. And yeah, a trace up to here makes contact, but then it doesn't go any further. So yeah, I'm going to clean this, remove the copper there, I think, and then bodge this just with a wire. The easiest way to fix this would just be running wire from here to the pad it's supposed to land. So I guess that's what I'm going to do. Just cleaning up the ripped out trace there, so it doesn't make any shorts or anything like that. So I'm actually deliberately breaking this even more, so it doesn't short out. Is the trace next to it okay? That's the next big question. Okay, so that trace is okay. I'm going to run a wire. Easy as that, and that should fix our problem here. And of course I'm going to have to replace the socket for the SID chip, because we want this to be a fully functional Commodore 64. I'm just going to put some fresh solder on both of these spots. Let me see. This is supposed to go here. And then run one of my magnet wire bodge wires there. These are relatively easy to work with. You just melt the insulation on these wires and they stick pretty well usually. And I'm going to use a pair of tweezers for this operation because I don't want to burn my hand. This is basically just enamel wire. I know it as magnet wire. This has a lacquer layer on it to insulate it, which makes it very handy. It's pretty stiff wire, but relatively thin. So this is pretty perfect for bodging things like this. Yeah, that should be our new reset signal connection. Let's double check. Reset. Yup. 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 Now we have a connection to our processor over here. You can't see it because I forgot to adjust the camera. But trust me. I'm just going to quickly re-solder some of the shoddier solder joints that I did on the CAA and then clean this up. Should put a socket in and then clean it up. Yeah, but this is the culprit basically, our reset connection. That was that, I guess. Let's put a nice socket in here. We should probably do a quick function test while we're at it before I put anything else in there. Let's see if our bot fixed the behavior with the cursor there. Should turn on the power supply. Yep, that was the whole point of this fault, the reset signal not getting to the CIA. And that didn't initialize, and the timers were there from the processor, but the chip couldn't interpret them because it was just idling, basically. So just going to put a socket in there to be able to put a SID in there. Just going to solder all the pins and put the nano swin SID in there, clean everything up again, and then we're going to do a more in-depth function test, I guess. And this would have taken me ages to find without an oscilloscope, actually. Maybe with the logic probe it would be possible to see that the reset signal is not coming through, or even by just inspecting the board more closely. But yeah, as I said, I was suspecting the clocks not working correctly. So I didn't really look at the reset line at all. I probably checked the system reset when I first worked on this. It's one of the things I usually do. And yeah, I usually check that if the signal arrives at the processor, but not if the signal arrives at all the chips. Which of course, as you've just seen, is also very important for the system to fully work. I have my Kung Fu Flash connected up now. I'm also probably going to connect a keyboard to this, so we have the full functionality here. So let's see if we get this working at all. Yeah, now we have music as well. That's Last Ninja there. So let's start something. Yeah, the joystick works. Does the keyboard work? Yep. I'm just going to run the dead test from here again, I guess. Let's see if we get the timers displayed correctly now, which we technically should, because the CIA was fine as far as I remember. Yep, and as you can see, our clocks are now AM and PM, 11 seconds. Both of them run at the same clock speed, basically. So that means that fixed that problem. Our SID is also outputting sound now, which is nice. So that missing reset line, or broken reset line, was all that was to it. Was the reset line that goes to the SID chip, and the reset line goes from the SID chip to the CAA. Maybe that's useful for somebody else that encounters a similar problem. Pretty confident that the rest of the system works fine, but I'm probably still going to insert the proper full diagnostics with the harness that I have and just test that fully. We're going to see if the rest of the system is alright. So I have the full test harness for the original Commodore diagnostics that I'm going to run from my self-made cartridge here. Connected now, and if everything in this system works correctly, we are going to get all okay displays, except for the pedal inputs. I think the SID is going to show as not okay because the little nano swin SID doesn't have pedal inputs. Yeah, they're just not implemented. Other than that, this should all pass the tests, hopefully. Let's see. And we should hear the sound test as well now with the nano swin SID in there. Yeah, control port shows as bad and the SID shows as bad there. Control port because the pedals don't work. Sound test, I don't know if you can even hear that. It's pretty silent. And the 6581 is our SID chip. That shows as bad, just as I predicted. The rest seems to be fine. Winner! Yeah, that was kind of an easy fix, wasn't it? But I spent a couple of hours with this before. Hope to do this board justice. It's probably going to go into a new case. Maybe I'm even going to buy a new case for this. This is kind of my Kim Memorial C64. I'm pretty happy. Hope you learned something from this, maybe. Maybe if it's even that the CAAs need a clock to function and the reset signal. Or maybe that the reset signal for the CAA number 1 goes through the SID chip on these shortboards. If you ever wondered what my start sound for my videos is from, it's from this game, Flip and Flop. This is a First Star Software game. And that's my startup sound. This is actually a pretty nice game and one of the first games I played back in the day on the C64, because my father had it. You play a monkey or a kangaroo. This C64 with the slightly sad background story, or it wasn't sad when I got this, but it's kind of sad now. This is now fully fixed and I'm going to use this in the future. Yeah, there's always a risk of breaking traces, no matter how careful you are and how skilled you are. I think Kim was pretty skilled. He did quite a few repairs and recapping things and stuff like that on his retro computers. These things can happen and they can really kick your behind sometimes, because it's just one single trace that is cut somewhere. And that can be really tiresome to troubleshoot, but thankfully I found that out with the scope pretty quickly. Hope this was informative and maybe a bit entertaining. Shout out to Kim, wherever you are, for sending me this, and thank you for your time, and especially thanks to my supporters on Patreon and on Ko-fi and on the YouTube channel memberships page. If you want to give me some support, the links are in the video description. That's it for today. Thanks for watching. I'm Jan Beta. See you next time. Bye! Oh.